As we all know that enterprises are rushing to implement AI at a scale, but as they do that, they face increasing complexity, especially around GPU orchestration, high-speed networking, and obviously compliance. Now, Mirantis is stepping into the gap with the industry's first AI factory reference architecture built on Cordant AI, designed to get AI workloads up and running in days, not months. Today, I am joined with once again Shaun O'Mara, CTO, and Randy Bias, VP of Open Source Strategy at Mirantis, to unpack what this means for your infrastructure strategy and how this platform helps both DevOps teams and technology leaders to build secure, sovereign, and high-performance AI systems. Randy, Shaun, it's great to have you back on the show.
It's always great to be here. Good to see you.
It's great to be here.
To start, can you just walk us through what exactly the AI factory reference architecture is and how it supports building, operating, and optimizing AI ML infrastructure at scale?
We as a company have a long background in building large-scale infrastructure. And we wanted to share that knowledge and that understanding that we have in this new market where people are starting to focus on all the challenges around building GPU-based infrastructure. And I think a key thing about GPU-based infrastructure is it's not just about the GPUs, it's about the whole infrastructure stack. And in many ways, we've moved back to the world of the mainframe, where applications are tightly coupled to the whole infrastructure stack. And so we wanted to show the work that we've done and the requirements that need to be put in place to build effective large-scale infrastructure stacks that can support application contracts for infrastructure.
Randy, do you want to add anything?
Yeah, so it's interesting. These systems are a very different architecture than the typical enterprise data center, but they have a lot in common with traditional supercomputing or high performance computing systems, with which both Shaun and I have some previous experience with. And so it's really important to help people understand those differences and why things like non-blocking networks and maximum east-west traffic matters, why minimizing latency matters, all these things related to making your GPU-based applications effective. And so we really want to be able to get into real depth about that. That's why that white paper is, 80 pages, Shaun, I think? 65, 80 pages.
And growing. It's a living document, so people should check back regularly to see as we add to it and as we expand on it.
Excellent. Now, when I listen to both of you, I also want to know what core capabilities does this reference design offer, especially around rapid provisioning, composability, and you mentioned interoperable GPUs, networking, and of course security.
I think everybody at this point knows how to build a private or public cloud, right? You kind of know what the whole system looks like. I don't think as many people have experience with what supercomputing systems look like. And one of the things that's very different, which Shaun was basically alluding to earlier, is you're moving towards a model where you're aggregating systems together and trying to make them look like a single system. So you're trying to take 8, 16, 24, 32 GPUs and put them together for a single system, but it looks like one single GPU, one single set of contiguous memory. You're trying to wire it all together. It's very different from the scale out model. As Shaun was saying, it's kind of more like mainframes. It's more like supercomputing in the past. And so when you're trying to put all these systems together and make them look like one, you run into very specific kinds of challenges around storage, networking, how the systems work, rack locality, whether things are close together. You have to use different kinds of schedulers. You have to use things like Slurm and Slinky, kind of classic supercomputing schedulers that understand, the proximity of the systems to each other so that you can put your workload in the right place and get kind of the expected performance and throughput.
I think adding to that, when we start to expand out from this specific hardware infrastructure, we're also starting to look at what are all the surrounding systems that are necessary for cloud service providers to be effective. The big players out there like NVIDIA have very specific reference architectures, but they leave the delivery of multi-tenancy, multi-cluster setups to the vendors. They don't provide that themselves. So one of the areas which we're trying to really focus on is how can cloud providers provide those services and all the supporting services, the DNSs, the identity management. It's a much broader problem just making and providing access to GPUs and to the networking to support that GPUs. It's the whole ecosystem around it so that cloud service providers can sell access to those GPUs, that they can provision Kubernetes clusters on demand with the right setup from the beginning. I think there's also a major day one challenge. There is so much complexity in this infrastructure. And as Randy pointed out, there is so much that's interconnected, that all these dependencies between RDMA networking, NVIDIA's NVLink, as well as potentially InfiniBand and slightly older architectures. Then throw in the fact that you've got to be able to group GPUs, potential GPU slicing. All of this means that quite often this hardware is delivered, racked, and stacked, and then it can take months to sometimes years to get this hardware actually viable and working. And so as part of the reference, what we're also looking at is how do we distill that into a opinionated, albeit deployable out-of-the-box solution to help organizations get started faster and to potentially identify any gaps that they may have in the way that they're looking at their architecture from day one. Obviously, we're focused heavily on our Cordant product within the architecture, and Cordant gives us that ability to capture that reference in code and deliver that, but then providing people that ability to swap out the parts as needed. And so that's become a key part of why we shared such a detailed reference and why we'll continue to share it.
Now, you mentioned Cordant AI, and how do you see it will kind of free platform engineering teams and actually data scientists also from the whole complexity that comes with the, of course, AI. So they have the control, they have compliance, but they are free to focus on their areas and not architecture.
I think the key thing here is data scientists, just like developers, don't have the necessarily background or the time to be focusing on dealing with the challenges of getting infrastructure set up right. The more we can provide them access to infrastructure without barriers, we can make it easy for them to quickly deliver their workflows on top of that infrastructure and quickly identify where potential bottlenecks within that infrastructure is. We're focusing on the business value now and not on the value of building infrastructure. This is very expensive infrastructure. And we need to be able to provide fast and easy access to data scientists, developers. And as we move forward into the future where we start seeing more and more workloads becoming AI workloads, this infrastructure has to be able to be tuned to support that in the most efficient way possible. And these are all critical items that we're looking at from the point of view of the infrastructure. As we move up the stack, we're also starting to look at what tools developers are going to be using, what tools data scientists need to be effective, and providing that as part of the stack. And then I think, as we start to look at this, how do we evolve this as this industry changes? It's moving incredibly fast. If you just look at the frameworks for developers that have been developed over the last 2 to 3 years and how rapidly those are moving, we have to have a framework on which these things can be changed quickly to support new innovation. And that's all part of the key idea behind the way we've put the stack together and the composability that we're focusing on. Randy, maybe add some color around what the work that you're starting to do around the agentic AI stack here as well.
I mean, it's interesting because when cloud first kind of debuted, like one of the things it really did is it made infrastructure go away for developers, right? You just call an API, you get what you need, you can assemble it together, put your app on top of it. And it showed that developers really didn't want to worry about infrastructure. That service-based model was what they wanted. And data scientists are going to take that to the next level. They care even less about the infrastructure. They need to get from the data to the trained models and RAG or other kinds of systems that they're adding onto it. And then they need to deploy their applications and then measure, how things have changed. And they just want the infrastructure to disappear. So, part of what we're trying to make it to do here is to start to define sort of like that base reference architecture that everybody can use that's in a repeatable manner that goes beyond what NVIDIA gives you. Because NVIDIA just gives you the GPU pieces. Like virtualization is turned off on NVIDIA systems by default. So if you need to have a combination of compute and regular CPU compute and GPU compute, you got to have some place to meet it in the middle. And so that's why we were trying to put kind of that whole holistic solution together.
I was reading the press release. It also includes a curated content catalog with CI/CD, observability, and of course security tool. Can you also explain how that ecosystem integration accelerate, the whole MLOps workflow, and once again helps the team?
Yeah, so I think there's two parts to that. There is most of these modern workloads, most AI workloads today are running on Kubernetes. Kubernetes itself is a scheduler. It's a very powerful scheduler. It provides for a common abstraction across all of this infrastructure. But ultimately, what makes Kubernetes useful is all the services we put on top of Kubernetes. And we need a very simple and clear way for people to find those services. Again, going back to the whole idea, developers and data scientists don't want to care about all the complexity of the infrastructure. So if we can make all those services they need ready to go, easy to deploy, one click, or their administrators can quickly put those onto the platforms for them, we're reducing the friction. We're giving much more standardization, and we're simplifying the experience. If we go into the MLOps framework, every workflow, every user is going to have a slightly different approach to the way they do things. And again, by providing the catalog of tools that they can then compose to meet their needs, not forcing them into a stack pattern where they have to use everything out of a particular stack. They can compose their own stack. They can pull their own components together to deliver on their needs, but do so with guardrails, do so with potential support. And I think what's really critical here is we as an organization become the glue that provides services to the end user. But we're able to work with all these other great companies in the industry who are also offering interesting services and make it easy for people to find their capabilities within the infrastructure, within the platform.
I'm just going to tag team a little bit there on what Shaun was saying, because it's not, we're still at the very beginning of understanding what these applications are going to look like when they're fully formed and broadly adopted inside the enterprise. But we can already see that we're going to go beyond large language models. When we look where there's been traction and success in enterprises, like we already can see in the healthcare industry, for example, that they're using image-based models with radiology images, and they're having great success already. And what you need to do, the kind of stack that you need for a visual model, is very, very different than what you need for a large language model, right? And so, kind of to Shaun's point, providing enterprises with sort of a toolbox that includes a bunch of our tools, but also anybody else's in the industry, and then allowing them to assemble it on a per application basis, whether it's agentic frameworks or different kinds of models, but basically to solve domain specific problems, I think accelerates enterprise adoption of these AI powered applications and lets enterprises focus on what's most important, which is delivering business value sooner rather than later.
When you're mentioning some of these use cases, and if you look at Mirantis history with, of course, OpenStack as well, this architecture also supports environment from on-prem, hybrid, all the way to edge. How are you ensuring, kind of consistency, security, and also compliance, looking at the, deployment targets or workloads?
That's been our bread and butter, right? So we have many, many financial institutions, many government organizations that we support for both OpenStack and Kubernetes. So we're really comfortable and familiar with kind of their regulatory and governmental compliance kind of requirements. And that's really about how you deliver kind of the packaging. Like everybody wants open source, but how you put it together, whether it's FIPS compliant, whether you've gotten certain kinds of certifications, and those things are really sort of about the know-how. And so we've got that, and we just roll that out further past the existing product line MOSC and MKE to Cordant, and Cordant really becomes the foundation going forward of a lot of our different products. So even MKE is moving to Cordant. We're putting virtualization on top of Cordant. It's really becoming that glue across all of the different, the entire product line, really, if I'm honest, right? We've always been based off of Kubernetes. Now we've got this super orchestrator for Kubernetes. So of course it becomes the glue for all the different pieces we put together. So, we just see it as a straight line continuation of all the good work that we've done with our existing customer base.
I mean, just to add a little color there, I think we talk about Kubernetes here and how Kubernetes fits into the ecosystem, but we're actually using Kubernetes as the super control plane here. And I think this is a critical point. We're not just doing Kubernetes. We still have OpenStack as part of the offering. We have alternate virtualization solutions. So we're trying to, cover a broader gamut of solution requirements. But by also having that centralized command and control component, which is critical part of Cordant, which allows us to declaratively define the requirements for an environment and for an expectation, and then validate that what is delivered is what was expected. And if something changes, we can reconcile that. That is part of one of the major ways we're able to ensure the governance within an environment. We're able to ensure those control points in the environment, but without being in the data path. So even if there is a failure on that control plane, we're not impacting the environment. And this is a big part of our whole way that we've looked at the architecture, that we've delivered on the software, and that the ethos of how we're thinking about moving into the future here, which is this composable stack that can have components added to it over time to start to deal with some more unique use cases. Interesting things like creating strong separation, multi-tenancy separation between the host and the networking infrastructure, but with still having that flexibility that comes from having network overlays and providing much deeper levels of security. So this is the iteration work that we're doing because we have this base to work off.
And considering the fact that you're involved with the OpenStack and Kubernetes now, OpenStack is part of Linux Foundation. Jonathan Bryce is now the new executive director of CNCF. What actually led Mirantis to formalize this reference architecture now? Was it like customer challenges, new hardware demands, or the way market is changing?
Little bit of all of the above. The market is changing rapidly, and we're seeing a lot of confusion, a lot of lack of understanding within the market about these architectures. There's a lot of opaqueness within the market about understanding what is needed at each layer here. So as part of our open source drive, we wanted to be a lot more open about that. It also helps us create a better point to start a dialogue and get feedback, both from our customers and our partners and the community. And I think that's an important part of this. We have, combined just between Randy and I, probably 60 plus years worth of infrastructure experience. Then throw in the rest of the business. We've got hundreds of years worth of infrastructure experience. And deep infrastructure experience is something that is quite rare, actually, in our industry, because infra wasn't cool for the last 5 to 10 years. It was very narrowly held in the pockets, specifically in the hyperscalers and the like. And it gives us an opportunity to share that knowledge and bluntly, show that we have a good understanding of this. And again, I'm going to say elicit feedback. We like feedback. Both Randy and I love a good argument, as do many of our colleagues. So we're very happy to get into a debate about the way we're doing things and get that feedback.
I think about it kind of like as Prometheus bringing fire down from the mountain. Like Shaun and I are sitting there talking about these architectures and how they're different, to enterprise data center, but look like old supercomputing platform, and nobody's talking about publicly. And then we see some reference architectures from some folks out there, and we look at it and we're like, man, this is missing everything. Like, it doesn't go deep on the network. It doesn't go into storage. It doesn't talk about different trade-offs and decisions you need to make. And we're like, why shouldn't we just tell people what we know? Right? I mean, we're an open source company. We're not, we don't have like a lot of closed source components and just a few. So it makes more sense for us to share our knowledge more broadly. And it really reminds me of kind of the early days of cloud computing, 2010, 2011, very few people understood how to put the systems together. So I just had fun going out and documenting that stuff, writing white papers, explaining how different things like oversubscription worked, explaining how margins worked, explaining that AWS had very high margins, not 5% margins like their retail side. And it just got us into that frothy conversation. And so, I hope that Shaun and I are jumpstarting that here, and we will get into some interesting conversations with folks.
Yeah, let's close off and just say that I think what's important about open source is not just about code. It's about sharing of knowledge. It's about sharing of understanding. It's about people coming in, to a certain extent, we call it scratching their own itch. But by sharing knowledge, we actually are able to grow that open source space and grow the quality of what our customers, we are a business at the end of the day, what our customers are able to receive. And that's important to us as well.
Last question before we wrap this up is, if you look, at this, how do you expect this reference architecture to evolve, perhaps around, agentic AI, or even confidential computing consortium is also there. So just talk about how do you see it evolve over time?
It is going to evolve, and I'll leave Randy to answer the second part of that, but it's going to evolve from a technology point of view as we learn more, as we implement more of these. And as new technologies get released. That's at the very base. But if we really want to think about how agentic works, agentic workloads are going to need to create a contract with infrastructure to deliver on the quality of service that's required. We're also going to be looking at how do we create a very clear way to protect those workloads from each other, and ensure performance, but also be able to accelerate the usage of those workloads. And I'll let Randy continue that because he's doing some deep work in that space at the moment, and it'd be good to hear at a high level what's going on there.
This call is really about kind of our AI factory reference architecture. As we expand that, we'll go deeper on the infrastructure side, but we're starting to look past that. We're starting to look at, what does it mean for an enterprise to adopt, agentic systems, agentic workflows. And what we see right now is that it's moving so fast that it's like a lot of the other technology, revolutions that happened in the past, and a lot of things around security and compliance, governance are kind of being left behind while we are trying to implement, these tools and get business value out of them. So we think it's really important because there's more danger of data leakage, of improper use of these systems than ever before. We think it's really important to get out in front of that. So we have some plans there to basically build some open source capabilities up the stack where we can do things like policy enforcement, make sure that agents are only allowed to talk to what they're allowed to talk to, make sure that they're clearly authenticated, make sure that data is encrypted in transit and at rest, to basically provide all those guarantees that a typical enterprise would want to if they're going to deploy agents in a secure way. And that's something we're working on now. I don't want to go too deep on it, but it really complements everything else we've been doing. It just adds on top of it. So we've got the baseline AI factory, which includes the core infrastructure and then kind of a GPU platform for inference and training or fine tuning. And then on top of that, kind of an agentic management system will be something that we're coming out with in the near future. And we're going to bring all of that expertise that we've got from, running some of the world's largest financial systems and make sure that enterprises can adopt this stuff in a way that makes sense.
Watch this space. Cool stuff coming.
Shaun, Randy, thank you so much for sharing these insights. It's quite clear that the industry is moving fast, that the challenges around AI infrastructure aren't going away anytime soon. But these kinds of initiatives are going to help teams move faster, be smarter, and do things more securely. So thanks for your great insights. And I look forward to continue this conversation as I can see a lot of things are already in the pipeline. But I really appreciate your time today. Thank you.
Thanks, Swap.
Great seeing you, Swap.